Alright, so in this video, I'm going to be talking about three specific molecules and then their molecular geometry. So the first molecule we'll be talking about is H2O, also commonly referred to as just water. And then here you can see the Lewis dot structure of H2O. So pretty much what you have is two hydrogens on each side. And the hydrogens can only have two electrons, so they only have one bond each. And then the oxygen has two lone pairs on top of it. So there's two bonds and then two bonding pairs and then two lone pairs. And then that results in a very bent shape. So there's two types of bent shapes. So one where there's only one lone pair and then one where there's two lone pairs. So because there's two lone pairs, the bond angle is reduced even further, resulting in an angle of 105 degrees. So the bent shape just pushes it together, and here, as you can see, it results in a structure looking something like that, maybe even closer together. Alright, so the next molecule we're talking about is CH4. So this is a structure. As you can see, there's no lone pairs or leftover valence electrons. Everything is bonded, so there's four bonds. All the hydrogens are filled, and then the carbon molecule is also satisfied. And then this results in a tetrahedral shape, and the word tetrahedral is just because there's four and there's no extra lone pairs. And then tetrahedrals have an angle of 109.5 degrees. So, yeah. And the last molecule we'll be looking at is NH3. And then here is the structure. So as you can see, there's one lone pair, unlike in the previous CH4. And then there's three bonds. All of them are single pairs. And then this results in a trigonal pyramid, trigonal pyramidal shape. So trigonal pyramidal is if there's three separate molecules, three separate atoms other than the central atom, plus a lone pair. If there wasn't a lone pair, then it would just be the trigonal planar. And then this results in an angle of 107 degrees. It's different than the tetrahedral since the lone pair pushes the angle together even more, resulting in a tighter angle. So yeah, that's pretty much it. All right, thank you.